In this lesson, we're going to be classifying triangles. You can classify triangles by their sides as well as by their angle measures. So starting with classifying triangles by their sides, triangles can be either scalene, isosceles, or equilateral. Scalene triangles, all three sides have a different measure. Isosceles triangles have at least two congruent sides. In equilateral triangles, all three sides are congruent. When you classify triangles by their angles, they can be classified as either acute, obtuse, or right. Acute triangles have three acute angles. Obtuse triangles have one obtuse angle, and right triangles have one right angle. Note also that if a triangle is equilateral, then it is also equiangular. So in this example, we want to classify the triangle by its angle and by its sides. Since all three angles are acute, this is an acute triangle. And all three sides have different measures, so that's scalene. In this example, we have one obtuse angle in the triangle, so this is an obtuse triangle. And two of the sides are congruent, so this would be an isosceles triangle by sides. Here we have two congruent angles. So for these problems, we would just need to go off of how the angles appear in the figure, and all three of the angles are clearly acute angles. So this would be an acute triangle. And we have two congruent sides, so this is going to be an isosceles triangle. For this example, we have one right angle. So this is a right triangle, and there's no indication about the measure for the sides, so we need to assume that all three sides have different measures, and we would therefore classify the triangle as scalene. In this figure, we want to identify all the isosceles triangles. So one of the triangles that's clearly isosceles is triangle BED is a isosceles triangle, which we can also call that triangle BDE. And then also triangle BDC is also another isosceles triangle. And ABD is an equilateral triangle, so it is also isosceles. The scalene triangles in the figure, we have triangle EDC, there's a scalene triangle, and ABC is also a scalene triangle. For this example, we want to classify the triangle by its angle and by its sides. So to classify it by its angle, we want to graph all three coordinates, and then connect those coordinates with segments. After we've graphed it, we can clearly see that this is going to be an acute triangle. And then to classify the triangle by its sides, we need to find the measure of all three sides. So we're going to use the distance formula to find the measure of all three sides. Once we do all of the computation using the distance formula, we determine that the length of KP is going to be the square root of 26. KL would also be the square root of 26. And then LP would be the square root of 32. So since we have two congruent sides, we would classify the triangle as isosceles. And again, we are using the graph to determine that it's an acute triangle. Same process for this example, just a different set of coordinates. So first thing we want to do is graph all three coordinates to identify what the triangle is going to look like. This is clearly an acute triangle. All three of those angles are acute. And then again, we're going to use the distance formula to determine the length of each of the three sides of the triangle. So once we do all of the calculations using the distance formula, we determine that KP has a length of the square root of 53, KL is the square root of 52, and LP is the square root of 25, so this would be a scalene triangle.